All right, and welcome to our last week of class. We're going to look at Chapter 9, which will be the last piece we look at in the book. However, I'm going to encourage you, if you find this at all fun, the reality is Python is a great language to begin with. You can start to create your own kinds of games. You can do all kinds of interesting small pieces of software. And more importantly, I think what the really interesting thing with Python is a lot of different websites, development tools are all designed, and they develop them in Python, and then they make the code available. So if you would like to edit that, you certainly have that power and that ability to edit that software and change it for your own use. And you're thinking, well, I didn't really get A, B, and C, but the reality is some of this is fairly easy. And so once you see the code in there, if I want to edit how many times, for example, a game loops through or other things, you can certainly do that pretty easily. So the last chapter, and one of the reasons I selected this book was based on the idea that we do a lot of games, and games seem to be more fun than making programs that tell you a name 37 times. So we're going to look at a blackjack game. So we're going to look at how we can create that using this idea of those objects. So we all pretty much know what blackjack is. Does anybody in here not know about blackjack? Okay, good. So it's a card game, one of the most popular in a casino. And in fact, my child, who is a pit boss now, says that if you're going to go into a casino, this is the game to play. It actually has the odds less stacked against you than any other card game in the casino. So in other words, if you know the basic rules, you play it, you could, in theory, come out better off, although the house will eventually still always win, but the odds are closer to your favor. So we know how many cards there are in a deck. There's generally 52. We know that number cards count as their face. An ace is either a 1 or 11. So what you're trying to do is get to a set of cards that get close to or to 21, but not going over. So there's rules then for the computer or the dealer in this particular case, however you want to look at it. And so you have the ability then, once your cards are dealt, that you can get additional cards. And so we need to think about then, how are we going to create these objects? How are we going to be able to create messages that can pass back and forth between the two of them? So between different objects or different players, or between the player and the computer, or the player and the dealer. So we need to think about that interaction between two objects. And so we looked at last chapter, we looked very briefly at the idea of public and private, and we're going to look at that again and try to see if we can't come up with some ways where we can move pieces between. So on page 249, they introduced something called the Alien Blaster program, and so we're going to take a look at it. So we're going to edit it in our idle again. So really short little program, and you notice we have a class player. So in this particular case, we could create two different objects. So a player, and then if you notice here, it's got a method called blast. We have a class called alien, so we're going to create an alien object, and it's got a class called die. Well, that's interesting, or a method called die. So what we're looking at is, how do we get a message passed from one particular object to another? And so one of the tools you might want to use when you start doing this, and we looked at it before, is something like a modeling language. So in other words, you might want to draw out how some of this works. So we create a class player, so nothing different than we've done before. Now we also created a second class. And in fact, depending on the size of a program, we may have 20 or 30 or more of different classes, and then we could call them repeatedly. We could invoke player and alien and create an entire cast of characters because we have those different ones. So here is where it's kind of interesting. So this is nothing new. We created a class. Inside that class, we created a method called blast. And all that does is prints out the player blasts an enemy. But here's where it does look a little different. Notice that it calls the class method internally. So this particular thing, when we run blast, then executes enemy.die. So it's going to run then this particular piece. So that's where this is a little different than any other thing we've done so far. So our main then, we invoke a hero, we invoke an invader, and then we use something a little different. So notice here we have hero.blast. So player.blast, so it's going to run this. So let's see what happens. When we run this, so death of an alien, so that's our line here. Move that over just a little bit so we can see. The player blasts an enemy. So in other words, this line runs. It then executes enemy.die, which forces it to come down here, and then says, oh, the alien gasps and dies. Tell my 1.6 million larvae that I love them. So that's one method we can start thinking about how we can pass these messages back and forth. So we can create these objects, and they have some independence, but we can also then pass items back into them. So we're going to look at how then do we start creating a program then to deal with cards. And so we know that cards have a couple of things in them. So if I use an editor, I know that cards have, we might call them whatever. We know we have an ace, a king, a queen, a jack, and then a 10, 9, 8, 7, blah, blah, blah. So we know that we have all of these items. And we could rank them then based on their point value, depending on how we want to do it. And we also know that we have suits. So not only is it going to be an ace, but it's going to be an ace of spades, for example. It might be clubs, hearts. So we're going to have a combination of those two. And that's how we arrive at all 52 cards. So by using this combination, we can narrow it down. Now, to begin with, we're going to look at the idea of only having 52 cards in our deck. Now, the reality is if I go into a casino, are they going to play with just one deck? No. They'll have multiple decks in there, and that adds a little bit to our complexity. But we're going to look at how can we create a deck of cards, some kind of an object. So what we might do, so we know how these cards are going to work. So we're going to create class card. and we're creating an object. So we might create, and our book uses the term ranks, and that works well. So we're going to create a group. So we have aces, and it makes some sense to think about them in terms of point values. And so we're going from low to high, although we know that the ace can represent both high and lows. So we created our rank of cards, and I'm going to go ahead and close this out early just so I don't have to type that much. Well, we're also going to create suits, and we do a very similar technique here. So notice those are all in quotes because these are going to be strings. All right. So, and we're going to do initialization, or that constructor. This underscores would be helpful rather than so in other words, we're taking those two pieces that we created all right. So nothing out of the ordinary. Now, we're going to look at starting to create some other items in there. So backwards one line so we get back out. We're going to also define and remember when I use the underscore, it becomes a private string. So notice we're combining those, and it passes a value back out. So that rep then concatenates rank and suit together so that we can get a card that's got both suit and rank. In other words, an individual unique card in our particular case. So now I'm going to cheat a little bit so you don't have to watch my horrible typing up here while I'm trying to do this. And you can find these available online. So this becomes what I just looked at. So here's class. Now here's the entire piece of it, and I didn't type out all of that, obviously. So that gives us then the ability to create a card, and in fact we can create any number of cards. Are you ready? Oh, okay. Zero's going to last that long on battery? Okay. Look. Okay. Let me pause this then. All right, sorry about that. I had to go fix a classroom real quickly. So the next piece we're going to do then is this idea of we created cards. Now we're going to create a hand. In other words, that group of cards you get dealt. So, or once again, we're going to define a class. So class hand. We have a constructor. So in other words, we run as soon as we create that class, we create one. So we have our private string method again. So This particular string method includes a couple of details we hadn't seen before. So let's take a look and see what that does. So if self cards exist, so in other words, if a card is existing, we're going to pass in that card plus a. So let's take a look and see. We'll show you what that does. Else, it's going to return the value of empty. So if a card exists, otherwise it says. So the reality is we know that when we create this hand, we don't know how many cards there's going to be in it. And so that's one of the things we do. So we create a clear. So in other words, we can clear out our hand. We can append. So in other words, we add to our card. And then a way to get rid of a card. So let's look at our main then. So our main creates then card 1. So in other words, it printed a card object. So let's take a look and see what that looks like when it runs. So when this runs, that's a card object, AC. So in other words, an ace of clubs. So we wanted to print out the entire value of card 1. We created it. Here, so card 2, we created rank 2 suite clubs, a 3 of clubs, a 4 of clubs, and a 5 of clubs. So here we can print them individually. So we printed out 2C, 3C, 4C, 5C. And remembering what those represent. So next we print out the hand that's existing. So before we add any cards, it returns that empty string. So notice here, if I go back up here, see there's no cards present, so it's going to return empty. So rep is then empty, and that's what's passed back out is this rep value right there. So once I add a card, so this function hand, so my hand before, my hand after, so we're going to add 1, 2, 3, 4, 5 cards. And so notice this add function then, that's where we append it to the original value. So we create 1, 2, 3, 4, 5 cards, so it becomes AC, 2C, 3C. So it then gives us a hand. So printing my hand after adding 5 cards. Then we can print those individual as we go to show you that my hand keeps growing. So if I wanted to, what I could do is change this just slightly. And I could show you that evolution as that hand grows. It's going to say yes, we want to save it. And so now, notice here, printing my hand before any cards, it's empty. And then we have 1 card, then 2, then 3, then 4. And so then eventually we have the entire set of 5 cards in our hand. So we then, one of the interesting things is we want to move cards from one spot to another. So if I think of a game like Go Fish, where I can move cards from one area to another. So your hand equals hand. So in other words, we're moving them in this fashion here. So my hand.give. So in other words, this give function. So we remove it from our hand and put it in the other hand. So we do that twice. And it says, my first cards from your hand are the ace of clubs and the two of clubs. And then, so it hands those off, and then it keeps the 3, 4, and 5 of clubs. I then clear it. So my hand.clear. After I clear it. And so then that gives us a way to maneuver these cards around a little bit. So what this gives us then is a basis for us to begin looking at how do I create a card program to create a game. Now, one of the things, there's a new term we want to talk about, and that new term we're going to look at is something called inheritance. So inheritance is very similar to what you think about when you first hear inheritance. Yay, I'm going to get something. Well, in inheritance, what we get is the ability to create a class based on an existing class. So if I think about student information system here at Peru, I have a group called students, I have a group called faculty, I may have a group called contract workers. I can get all of that information, though, from a superclass, if you wanted to call it, called people. So you can create a class based on another class. So let's take a look at what we're looking at. So we're going to look at a slightly modified version of this. So this is a very similar program. So we've modified it just a little bit. And we can actually look at the differences between the two if you want to. So up here we created a class card. Very similar. Nothing different there. We created a class hand. All the things are very similar there. But what we did add is now we had something for called a class deck. And a deck is a group of cards. So it doesn't make sense to go back and recreate that from scratch when I can inherit from hand. So here's this hand. I can inherit everything I need to and then add an additional piece to it. So in other words, I created a base class called hand, and then I grew that into something called deck. So let's take a look at what it does. So what does deck do? So deck then says populates. So we have a function called populate. So we know that we got the base information from hand. So if I go back up to hand, everything in hand comes into deck. So we're going to populate. And so for suiting card suits, so in other words, we're going to run a loop that goes through all 4 suits. And then we put another loop inside of that so it creates a rank. And it creates a card every time that happens. So what that essentially is going to do is you put a loop inside of a loop, and so it runs the outer loop 4 times and the inside loop how many times? How many cards are there in a deck? 52. So it's going to run the outside loop 4 times and the inside loop 13 times. So in other words, the 2 through 10 plus the ace, king, queen. So this creates then an entire deck of cards. So immediately, if I wanted to create a deck that had multiple suits, so in other words, it was composed of more than one deck of cards, I could run this particular piece, and I could put this then inside of another loop. So I could do this. So I could create another for loop So if I had a 4-card suit, or I wanted a 4-card shoe, I could create this and run this another 4 times. Right now, we've created one deck of cards. So go back to where I was at. Okay, so this creates a deck of cards. Now the problem with that is now they're all in a weird order. So they're all by suit and listed in order. And that's not really very useful to us. So we need a shuffle function. Okay, so I have a shuffle function we've added. So we've extended past what was going to be in the original one. So we had the clear, the add, and the give, and now we're adding a shuffle to deck. So one of the things that's very handy is remember that we have this thing. So we imported random. Now we could have imported that at the beginning of our game also, but this is where we're going to use it, so it's handy for it to be in this particular location. And then we random shuffle all of our cards. Well, that's pretty slick. And again, in any other programming language, this is going to take a long time to construct a shuffle feature. We'd have to come up with some way to randomize each card. One line, boom, we're done in Python. So again, it's really great for games. And then we have a deal function. So that deal function, so we're looking at self, we're looking at hand, so we go back up to hand, okay. And we're looking at per hand equals 1. So in other words, we deal 1 card each hand. So it also gives us the ability then to tell if we're out of cards. So here we go through all of our loop. If self cards, so if the top card equals 0, then it means we've reverted back to that top piece and we're out of cards. So it's a quick way that we can look at how we ran out of cards. So again, all of this is in the book, so make sure you look at it and read through and look at it. So page 260 looks at using that derived class. So we defined a shuffle on 261. 2 hand objects here, so it gives us this piece pretty easily. So here we're going to create a deck. So I create a new deck. So that runs the deck function. And by running that deck function, it automatically comes up and it says I inherited all this from hand. So it creates a deck and it'll print that deck. So let's look at what happens then when we run. So here we are here, we're at the print deck. So we created a new deck. But it's empty. We didn't populate it yet. We didn't create anything in there. So when I create that new deck and I printed it, it's going to say, hey, you're empty. Okay. And notice, is that empty function anywhere in deck? No, it's pulling that out of this piece up here. So that just proves to us that it really is an inherited class. So we're going to populate the deck. So our next step then, so we populate. So we run this function, populate. So it populates that deck. And notice though, those are all in a specific order. So we have ace of clubs, 2 of clubs, and it goes in a specific order. And so then we have ace of diamonds. And again, that wouldn't be very helpful for us if we're playing blackjack. It'd make it a little easier to win, but also for the house to win. So we need to shuffle the deck. So the next one we're going to run is shuffle the deck. So we shuffle the deck and then we reprint it. Notice now it's in random order. So now we're going to create my hand and your hand. So we're going to create 5 cards for each hand. So this might be a good way to look at a poker game, for example. So I'm going to deal 5 cards to my hand and 5 cards to your hand. So that gives us then these cards in our hand. Now what we've done is, remember that move function that we created before, so we could create it from one hand to another? Well, we used that function to move it from the deck to your hands. So if I look at the deck now, because we didn't want to just grab a number and have a duplicated value in there. So now look at this deck being smaller. Okay. So what we want to do is be able to pull those out and use them, and also create a smaller deck size as it goes. So as this deck gets smaller, eventually we're going to say, hey, we're out of cards. So now we're going to clear the deck, and then we can exit. So that just shows us how we can manipulate those. So we could go in and say, well, you know, maybe I really want to create so now notice we have to come down here. We'll have to add so we can pass all those pieces in. And so let's see what happens if we try to manipulate that. So run, yes. Okay. So why is it only showing me that I dealt my hand and your hand? Well, notice here I didn't print, so I would have to add another piece to actually display that. So print so we would have to run this extra piece. So now we'll run it. All right, and so now we've created it where it says my hand, your hand, and Dan's hand. So it pulls all those cards out. Well, we could change this. So notice we could change that. Maybe we wanted, for whatever reason, we created a card game, and we want 15 cards in each hand. So notice we've got that base. So notice now, and this shows it a little more clearly. So ignore where it says 5 cards because I didn't change the text. So here's a hand of cards, here's a hand of cards, and here's a hand of cards. And that says, oh no, now we only have these number left in the deck. And again, that shows us that we're pulling them out and moving them from one spot to the other. And so in fact, if we wanted to, let's see what happens if we create an error condition on purpose. So notice it populated the deck, shuffled the deck, and then it ran into a problem because we tried to deal out more cards than what were there. And so it says, oh, out of cards, out of cards, out of cards. And then it shows us then after that, it says, hey, I dealt these cards to you, I dealt those cards, I dealt these cards, and now the deck's empty. So, but with So we can run that and you can experiment with that, but it gives you a base module. And so in this particular case, I ran 17 cards into each hand and left one in the deck, a King of Hearts. And so that gives us a way then to create and model and see how we can move these cards around. So once I created this, I know where all the cards are. I know how I moved them. But I have a little bit of an issue with this. So I'm now showing you your cards. I'm showing you my cards. What if I want a set of cards that don't display? So how often do we play a card game and you play cards face down? And so you don't want you to know them. So you'd have some kind of a blank value and some way to substitute those in. And you don't want other players to be able to see those. So we're going to look at a way very similar. So we're going to take this very similar code and we're going to modify it just slightly again. So let me close some of these windows out. Yes, I want to kill it. So once again, we're going to look at a card function. And so now again, we're looking at inheritance, but now we're going to do something interesting. I think it's interesting anyway. And we're going to create an additional attribute for that card. So let's look at our code here real quick. So class didn't change, same type of details. We created our ranks, suits, and in fact, if you want to ever play around with this and you wanted to say, well, what would happen if I had a deck that had 5 suits for whatever reason? I made a new kind of card, we can do that. So card didn't change, but now we created a class called unprintable card. So, and all that does, it says it's going to, a card that won't reveal its rank or suit when printed, and we have a private method internally, and it's going to return the phrase unprintable. So we now created one called positionable card. So all this changes is it's a card that can be face up or face down. So all we're doing is creating cards that are either face up or face down. So if it's face up, it's going to give you what the value is. If it's face down, it's going to give you the values of XX. And then we have a function called flip. And that flip changes it from face up to face down, or vice versa. So in other words, whatever its value is originally, it's going to change that. So a couple of things here as we look at this. So we know that this creates an object. This inherits everything that's inside a card, because notice it's an inherited function. This also inherits everything from card. So those same functions that are available here are available inside of both card and positionable card. So just so we know where you're at there. So let's take a look and see what happens when we try to utilize this. So card 1 becomes the ace of clubs, ace of diamonds, and ace of hearts. So in other words, card 1, card 2, and card 3 we didn't create a deck of them, we created 3 cards. We created card 2 as an unprintable card, ace of diamonds. and card 3 was a positionable card. So we're going to create a card, and it's still going to come back up here and run this card function because it's an inherited piece. So if we print card 1, so this is what we're going to get. We get ace of clubs. If we print card 2, excuse me, we'll notice card 2 is going to give us the value unprintable. So if we try to return a value, notice it's going to return that value unprintable. Now, more useful for us is this idea, though, of a positionable card or a flippable card, whatever you wanted to call it. So here we can print card 3, and card 3 then is ace of hearts, and then we're going to flip it. And when we flip that card, then we should get this value XX. So how do we flip it? Well, here we printed card 3. Here we use that dot notation, card 3 dot flip, and then we printed card 3. Well, interesting. So what happens if we run this again? Because we don't have any way to say whether it's flipped or not. We don't know its original state. So let's try that again. Let's see what happens if I do another one. And then print. And let's see what happens. So let's run this again. And notice we flip it. So it went from XX to AH. So we can flip those back and forth. So that'll be kind of handy when we start looking at how do we create something like a blackjack game where you hand a card one face up, one face down, that I can flip those. Once I created a card, now I have the tool that I can flip it back and forth, either reveal it or hide it. And so in other words, I can override. So because I've come in here and created a inherited class, I can override what's in the original class. So we can flip them back and forth. We could create additional ones. And so this gives us a really quick way to be able to hide those on the screen. Now later on, if you start getting into graphics, you could represent, so XX would represent a card flipped over or something else, but it gives you a numeric way to do it at this point. No. The most interesting piece of object-oriented programming is on page 267. So polymorphism says we can create a class, and that class allows us to look at objects and change our behavior based on the object itself. So if I pass in a value, so I've created a class, and I pass in a value for a numeric value, I pass in a string, it can change its behavior based on what we're handing it. And that's pretty powerful that we can create that. So it's that ability to change almost dynamically depending on what we're doing. So we do it all the time. If somebody gives us a sentence to repeat, we know what to do. If they say, hey, 2 plus 2, well, now we're trying to create that same kind of an ability programmatically. So before we had issues with, all right, if I wanted a string input and I got a text value, I had to do option A. If I had option B, because I got a numeric value. Well, this allows us to create classes that can handle both and deal with it easily. So our input could change depending on our user input, and our output then is changed based on what is in our code. So polymorphism has existed in theory before we had object-oriented programming. We could write lists of if, then, else statements and things to create something very similar to polymorphism, but we haven't had the true ability to just do that. So make sure you read polymorphism, what it's about. So in other words, if I ask for a card value, I now have three classes in this particular thing. So I have a card, unprintable card, and a positionable card. Based on what I ask for, it may give me a card, it may give me a non-printable, or it may give me a positionable card based on what I put into for input. And so we could create, when we create a game, the ability to get input and output that very similar way. And we'll show you here in just a second. So we looked at modules. So we've imported several. So we imported the pickle module, we've imported the random module, you may have imported the sys module when we looked at how to save things onto our file. Well, we can create our own modules. And again, programming is this interesting piece that we start with very basic concepts. Remember, there's only three different types of things we can do in programming. We can do a sequence, we can do some kind of a loop. I mean, there's really not a lot of things we can do, but we do them over and over and over again. So if we created something like a deck of cards and we want to use this piece over and over again, we could save our own module and be able to reuse that. So if I write a lot of card games, I'm going to think, well, all these pieces I use over and over again, so this deck piece, yeah, I may have a graphic piece out here that hooks in, but why am I putting this in my code every time? Why couldn't I just call module deck or cards or whatever I want to call it and have that available just like I do with that print function that it will work? So rather than have all this in my code, all I have to do is for example, say maybe deck.shuffle, and I've got a shuffled deck ready. So on page 267, we look at how you can start creating those modules. And so the other thing that's kind of interesting about these modules is if I go out and I start searching for things, I can find whole libraries of different modules. People have already done this and said, well, you know, there's 52 cards in a deck and there's 4 suits, and why do I reinvent the wheel every time? So on the bottom of page 267, we look at something called simple game. And so we'll load it here real quick so you don't have to see me type. And notice then, this particular module says, import games and random. Well, games is something new that we haven't seen. And in fact, we have to actually create that module called games. So when I look at this, it's really referencing this. So let's look at how do we create a class or a module here. So this is the model that creates a module called games. So we can store this. So let's take a look at what's in there. So class player. So we have a constructor. Once again, we have a name and a score. We have a string function, in other words, that private method internal that returns rep. So what this does is concatenate self-name plus score. We have the ability to ask a yes-no question. So in other words, that function's built in. We have this module ask number. So ask for a number within a range. And then if for some reason you tried to run this and not import it, here's what's going to give you, it's going to say, hey, you tried to run this directly and didn't import it. Okay. So how does it know to import that module? So let's see what happens when we run this. So how many players? Let's go all 5. So a couple of things. And apparently we've got an error because it doesn't like 5 players, but it did like 3. And so then it just spits out game results. So it spits out a name plus a game result. So when we say import games, notice the name of this file is games.py. And it will automatically try to find that file called games. Now, it doesn't look just in this particular module because notice random isn't in that folder. So there's a tip on page 270 where it says trap and it's got the little thing. So it talks about that. If a programmer created module isn't in the same directory, Python won't be able to find the modules. So there's a list of them that are in another location. If we want to use our own, we have to put it inside of the same folder. So it's not a big issue, but just something to be aware of. So the other thing is if you're turning in or trying to create one of these and you forget that games module. So if I were to change that name of that to games2, now I'll see what happens when I run this. And it says, hey, no module named games. So, oh, we didn't have it named correctly. And those kinds of silly things often get us into issues. So all this particular program did was imported games in a random function. And it said, while again is not equal to none, so in other words, we could loop this over again. So this is all a loop. Players, it's going to tell me those. And then we ask for a player name. So in other words, we've created that range of how many players there are. And it gives them a score of some sort. So it just creates a random score. So I look at what this module does then. So inside that module are a couple of things we're going to look at. So we have our while, but notice here we originally say there's nothing in players, and that players comes out of here. So it's pulling that class out of that module that we're importing. So here we have games.ask yes or no. So in other words, we're asking a yes or no question. So those things that we do all the time, instead of having to have all of that in our programming code, now we have one single line. So in other words, we're grabbing it from a module. The same way our print command goes through hundreds of lines to try to print, and we just simply say print. It can work that simple. So here are the game results. So ask yes or no, ask a number question. So all of those, so game.ask.number, So this is just another way. So we'll start back in on Thursday and look at this again, and we're getting closer to being able to create a blackjack program. So could we have created a blackjack program with what we already knew? Yeah. Before we ever even got to the idea of object-oriented programming or classes or inheritance, could we have constructed a blackjack program? Yeah. But this makes life a lot easier. And so there are some kinds of coding problems that work very well for object-oriented programming, and there are some that are a little more difficult because it doesn't fit the module or how that random object or that object-oriented programming works. But probably 95% of the programming we do today fits very well into this idea of object-oriented. We can create objects. So cards, decks of cards, players, all of those can be objects, and we'll see how we can interact with them. Well, the other thing with these objects, it's really easy once we create one to reuse it. So again, we've created a deck of cards. We've learned how to shuffle it. How many different kind of card games are there out there? So if I wanted to create a solitaire game, now I've got a way to get those cards. How do I start positioning them on the screen? So this is kind of the basis for how a lot of things are done. If I look at video game development, the reality is a lot of video game development is based on this idea of these modules that they've created. So if I look at an older game, perhaps Asteroids or something like that, all of these things are objects, and we've created a way to interact with them where their position on the screen is, how they behave, can all be a function inside of that object. All right, so get out of here, enjoy the rain, and we'll see you on Thursday.